This constructor is efficient and flexible. I feed magnetron plastics, which is what houses and ships are made of today, into moving art. It prints in the air in the wake of earlier scanned blueprints. Plastic comes out of the moving arm and solidifies. This thing starts working at one end of a ship or a house and completely finishes it at the other end, and only by following the blueprint. This popular scientific explanation of modern 3D printing is an excerpt from a short story by the famous American science fiction writer Murray Leinster. It was published back in 1945. Leinster believed that this is how we would design houses and spaceships in the distant future, and he turned out to be right, except for the fact that this distant future almost arrived in the early 21st century. Master of Crafts has already talked about the Ukrainian startup that uses additive technologies to design energy-efficient autonomous homes. On this occasion, UATV went to Odessa to learn how to use 3D printing to produce complex parts for the aerospace industry and more. We do 3D printing of ceramic products. The difference between our technology, which we developed at Kwambio, is that we can go through the entire production cycle from the idea to the finished product only using 3D printing technology and automating the entire production process as much as possible. Ukrainian Vladimir Usov founded a startup that made it possible to create objects from ceramics and related materials based on CAD models. This technology has many applications. Design and art are the primary ones. We can print objects and art objects processed in unique shapes that are almost impossible to create using traditional ceramic technology. It is also used in industry, the aerospace industry, which needs parts with complex shapes to be made in small quantities and reasonably quickly. The third field is medicine and healthcare. How is ceramic 3D printing different from regular 3D printing? How did a Ukrainian startup manage to come up with the unique idea of rapidly developing additive technologies? And how real is the idea that very soon people will be able to print new bones and even organs in the same way? All about the history of the worldwide success of Ukrainian innovation right now here on UATV. Writer Murray Leinster was born in 1896 and died in 1975. Just 5 years before the first prototypes of 3D printers appeared. In the 1980s, scientists discovered that polymers that solidify when exposed to rays of certain frequencies can be used in the creation of objects. Simply put, they shone some light on liquid plastic, which then solidified into the right shape. In July 1984, several French scientists patented such a production method, calling it stereolithography. However, the company to which they tried to sell the technology did not see any business prospects in it. Just 3 weeks after the French, American Chuck Hall patented a system for generating three-dimensional objects by creating a cross-sectional template of the formed object, using photopolymers and an ultraviolet laser. Today, Hall is considered the founding father of modern 3D printing, even though the technology itself has changed. Most people generally perceive 3D printing as a single technology that enables the printing of various products with different materials. In reality, it is a whole set, a whole stack of different technologies that are very different from each other. Today's main technology in 3D printing is the application of heated filament layer by a layer in accordance with CAD blueprint. In a word, just like Murray Leinster wrote. However, this method does not work with other harder substances due to the high melting points, like ceramics, for example. If you take a look at the first ceramic products at the Metropolitan Museum, which are 20,000 years old, and then at modern ceramic products, you'll see that the production method has not changed much. We have introduced an innovation into this old conservative industry, which makes it possible to produce ceramic products 10 times faster and create shapes that were previously impossible to create. Volodymyr was not into ceramics or clay modeling despite what you might think. When he's asked about his professional background at international conferences, he laughs it off. I always write Grammar School number 2, Odessa. They taught us English well there, which helped a lot. As for higher education, I graduated from the Faculty of Economics at Odessa National Maritime University with a degree in organization management. I'm not a professional designer, and I don't really know how to do anything really well, but I can do a bit of everything.
умею всего по чуть-чуть.
Volodymyr's first large startup had a truly ambitious goal to create a worldwide platform for 3D printing.
For example, now I see the beautiful vase.
The Ukrainians wanted to do something similar to how application markets work on smartphones with real objects. In other words, first, designers upload their 3D designs to a certain website.
And when you like it, just...
Then consumers, who can be in absolutely any part of the world, connect their printers to this system, print this model, pay for it. The money goes to the designer, and the platform takes its share. So it's a horizontal production model. There was an attempt to introduce something similar in the book market, to print on demand. The publishing house does not wait for the current circulation to be sold out. Instead, it prints an e-book when a customer puts in an order. Sounds reasonable and innovative, but just like print-on-demand of literature, the idea with remote printing has failed. That is because the printers that people could buy and use at home, personal devices, were fairly restricted in the use of materials and technologies. So all they could print were some crude-looking souvenirs. A sane person would not pay for that. In addition, the entire community of 3D printing fans are geeks, who are used to finding 3D models, editing and printing them on their own. So the idea of paying for a 3D printed object itself is quite unnatural for them. But the testing of this platform enabled Volodymyr and his colleagues to find out what users would like to order for 3D printing. In addition to metal and glass objects, people looked for ceramic objects. The additive technology that would have allowed that to be done simply did not exist at the time, and Ukrainians decided to take a risk by setting foot on this unexplored field. They developed a concept of ceramic 3D printing and applied to take part in one of the most prestigious business accelerators in the world, which helped startups like this one. They did not even allow us into the pitching session. That really struck a nerve with me, so we applied again. Found some common acquaintances in their top management. In the end, we were invited to take part in the acceleration program that was supposed to begin in just 2 months. And in the space of 2 years, we managed to develop the first stable and effective technology for ceramic 3D printing. And only for UATV, Vladimir Usov and his colleagues explained the essence of this technology, exactly how it differs from conventional 3D printing, where parts made this way are used today, and generally how it is done. In addition to plastic 3D printing, an additive manufacturing method with gypsum-based powder has existed for many years. The desired item is modeled in bulk material using a special solution. This way they create various figurines, souvenirs and models, but such objects are fairly fragile. Nevertheless, Ukrainian engineers took plaster 3D printing as the base and tried applying it to ceramics. Volodymyr recalls the most offensive strange case at the experimental stage. We mixed the ceramic powder literally on the first attempt. Our engineers just eyeballed it, and it was almost suitable for 3D printing of ceramic objects using old plaster printers. But no one wrote down the proportions, so it took us about a year to get back to this formula by analyzing every iteration and recording all the results. In addition, they had to first modify and then completely redesign the plaster printer. Today, the Ukrainian startup owns 6 patents for all elements of the technology, ranging from the structure of the printer to the composition of powder mixtures. The head of the 3D printing department, Roman Vaskovsky, explains the principle of how it operates. What is its magic? A special substance called binder is fed through the tube into the moving head. A liquid interacts with our powder, which results in gluing. In simpler terms, we add water to clay, and it sticks together. The object is printed with powder. Then a layer is added. In this case, one reservoir rises, while the other one falls. In the end, the product is located in the lower reservoir. Such printing is called binder jet 3D printing. A stream of sticky liquid binds together the area specified in the model. This gets around the main disadvantage of plastic printing, where elements that protrude at an angle can fall off before they manage to freeze. But a ceramic product is supported from all sides by unused powder. The next step is to remove it.
После того, как оно напечаталось,
After it is printed, we wait about 30 minutes for it to dry. Then we remove the product from here and clean it up a bit in the dedust chamber. After that, we fire it at a temperature of 1200 degrees, which makes it solid and enables it to take its final form. After that, it is glazed, fired again, and sent to the customer. There are almost no restrictions in terms of shapes. Thanks to the special composition of the powder, it is even possible to make an unbreakable ceramic mug. Then we saw that if the technology works for design and the art industry, it probably should work for other applications of ceramics. We discovered that ceramics is such a versatile material that is used in almost all areas related to the production and use of high-tech products. These small ceramic rings are used as consumables in high-temperature welding of submarine hulls. Earlier on, the American manufacturer had to order these parts to be cast from clay in the traditional way, which is both slow and inconvenient. Now, the strategic plant has Ukrainian 3D printers. They need a lot of these rings, and most importantly, they constantly needed new models of these rings. We needed to produce them very quickly, so we developed a special material for these rings, and they passed all the tests. They can even withstand more severe thermal shocks than rings made in the traditional way. Heat-resistant ceramic plates were used in the design of space shuttles, so that the coating was lightweight and did not melt when entering the atmosphere. The Ukrainian startup is currently working on printing such thermal coating for extremely small CubeSat satellites. So far, these spacecraft are disposable, as they are launched into the Earth's orbit without the possibility of return. The new protection will permit satellites to re-enter the atmosphere, so scientists will be able to conduct more experiments and the amount of debris in orbit will decrease. But Vladimir Usov regards medicine to be the most promising high-tech area for his 3D printing method. Today, a huge number of fractures do not heal completely. I myself am the owner of such a lucky fracture, which will never heal, so I have metal in my arm. Our technology enables the creation of an implant of a unique shape from organic bone tissue that will knit together and replace damaged areas. The base for the printing of such implants is hydroxyapatite, which is part of the composition of actual bones, and medical biopolymers. In theory, this will allow for a 0% chance of rejection, and thanks to the porous structure, blood vessels can sprout through the printed part. As of summer 2019, this technology is still passing the certification stage, and if everything goes well, clinical trials will begin shortly. But Vladimir Usov is thinking ahead and is already preparing to launch a global platform for the implantation of bone implants. So that when you have a fracture, you can go to a certified clinic that will use our technology, which will print a bone implant based on your MRI or CT scan, insert it into the damaged bone structure, and after a certain amount of time, it will become your organic bone. This small bone area can be printed in 30 to 40 minutes. This approach involves treating our body as parts. If something breaks, we replace it with a new part. That's if we always have technology available that allows us to print an organ or a bone, and on the other hand, an accurate 3D model, and we'll have a new bone again. Volodymyr Usov has no doubts that the technology of ceramic 3D printing developed by the Ukrainian will, sooner or later, be replicated and even improved by others, just like what happened with Chuck Hall's invention. That is why experiments in the Odessa laboratory haven't stopped for a minute to this very day in the continuing search to find new applications for this technology. And so, step by step, the future from science fiction is approaching where a fabricator machine can create any object in a matter of minutes.